This time we're going to talk about tangent, and to make it invertible, it has to again pass the horizontal line test. So I have to restrict the domain or restrict where the graph is going to be looked at, and so I'm going to look here. So this is pi over 2, and that's negative pi over 2. For an inverse, I switch the x and y axis. So now the y-axis has the pi over 2 and negative pi over 2. It's going to go through the origin like it did in the original graph. But now it's going to go towards the horizontal asymptotes here and here. And again, we have the inverse tangent notation or the arctangent notation. That's the same. So like inverse sine, I'm going to look from 0 to pi over 2. That's in the first quadrant. And then down from 0 to negative pi over 2. That's the fourth quadrant. And again, I'm going to go down to the fourth quadrant quickly in the negative direction instead of going all the way around through quadrants 1, 2, 3, and then 4. So tangent is negative 1. Well, that's when the x and y are the same, but one's positive, one's negative. And that's our negative 45-degree angle, or negative pi over 4. Negative root 3 over 3, well, it's negative. I have to be in the fourth quadrant. And remember how this came up when we used to have just negative 1 over root 3 before we rationalized the denominator. And so then if the y is negative 1 and the adjacent's root 3, then we have this angle. Here's the negative 1, here's the root 3. So that's the small 30-degree or pi over 6 angle, but it's negative because it's going down, negative pi over 6. You just have to think backwards. When is tangent 0? Well, that's when, if it's tangent to y over x, that's when y is 0, and y is 0 here. And so that's just 0. You have to remember, this is now the value, and we're looking for the angle. Inverse function, switch the x and the y. So as a review, since the inverse function takes a value, these are values, the value of sine can go from negative 1 to 1. The value of cosine can go from negative 1 to 1. The value for the tangent can go from negative infinity to positive infinity. The range are the angles, and for inverse sine, it's the first and fourth quadrants. And to get to the fourth quadrant, I do negative pi over 2. The same is true for tangent. It's the fourth and first quadrants. Students, notice, sine, I can go to negative pi over 2 and pi over 2. But for tangent, I cannot, because that's when tangent is undefined. And so I use the parentheses for tangent, but the brackets for sine. Remember, for inverse cosine, I'm looking at the first and second quadrants, so that includes from 0 to pi. This notation can be a little confusing, but just look. This is taking the inverse of a function, and that's inverse sine. This is taking an inverse of a number. Sine of x is a number. And to take the reciprocal of a number, I put it over that same number. And the inverse of sine is cosecant. These are not the same. This is the inverse of a function. This is the inverse of sine. Different, different, different. So the basic idea I want you to take away for all three of these is that you're plugging in a value and out's going to come an angle. Same is true for inverse cosine and inverse sine along with inverse sine. Inverse cosine and inverse tangent. So going back to how we did these earlier, the general solution hasn't changed. I have to give all possible solutions. One is sine negative. Well, that's in the third and fourth quadrants. I have a root 2 here. That must be that 45-degree angle in the third and fourth quadrants. 1 pi over 4, 2, 3, 4, 5 pi over 4, 6, 7 pi over 4. And then plus 2 pi k. K must be an integer to get all general solutions. Like we did before, we took the general solution, plugged it into a table. When I plugged in 0, I get the 5 pi over 4. If I plug in 1 for k, this is 2 pi plus something. Do you hear it? If you have 2 pi plus something, it's going to be bigger than 2 pi, and it's too big. The same thing here. If I plug in 0 for k, it blows that away. I'm left with 7 pi over 4. 8 pi over 4 is 2 pi, so this is okay. And then if I plug in 1 for k here, this becomes 2 pi plus something, and it's too big because I can only go to 2 pi. I can't plus or add anything. Now here's what can be confusing, but just catch this. This notation right here is inverse sine. That has to be between negative pi over 2 and pi over 2, right? So I'm going to go into the fourth quadrant, you're right. But if you say 7 pi over 4, you're wrong. It's not in this interval. I have to go backwards, negative pi over 4. You must say that. That way it's an inverse function. One question, one answer. This is the one answer. I can't use 7 pi over 4. So here, looking for the angle whose cosine value is root 3 over 2. It's positive, so I have to be in the first quadrant. Adjacent is root 3. Hypotenuse is 2. That's the small angle. That must be pi over 6. Inverse tangent here is positive. Has to be in the first quadrant. Root 3 over 1. The opposite is root 3. The adjacent is 1. That's that bigger angle that I know. That's pi over 3 or 60 degrees. Looking for the angle whose sine is 1. Well, sine is y over x. For that fraction to be 0, y has to be 0, and y is 0 there. So this is the 0 angle. Again, these are functions. I can only get one answer, so the answer has to be in radians. Cosine now is negative, so that's going to be towards the second quadrant. But cosine is x over r. One is x negative 1. It's here, and so that angle is pi. Inverse tangent is positive. It must be in the first quadrant. Y over x. Y is 1. X is root 3. So that's the smaller angle. And so that must be pi over 6. Because the small side's here, the big side's here. Okay, now, trick question. 2 is 2 over 1. This is a value. Sine is y over r, opposite over hypotenuse. How can the opposite be bigger than the hypotenuse? This is no solution, or undefined. Let's say undefined.